Okay, so before we went spring break, you guys turned in the paper reviews, so I'm going to go over some of those questions with you. So you have one question that have a lot of different type, like e raised to x raised to e, x raised to a number, or e raised to a number. So when you need to take the derivative of them, the first one is just 10 to the ex, right? And then this one, you need to treat the e like a number, so it's going to bring it down, and then the exponents is one less, right? And this one, you have a lot of experience, so it's negative 35x to the fourth, and then e to some number is just a regular number, so when you take a derivative, it would be a 0, right? So something like that. And the second one is ln, so you need to know ln when they have a function, it's going to be 1 over that, and take the derivative of this part. It's kind of like a chain, right? So, and then ln of x is just 1 over x, so something like that. So this one, because of that, you can actually reduce it, and because after you reduce all that, it would be 5 over x minus 1 over x, so you can actually combine the fraction. So you may want to write down the question and practice and double check the answer with me. Okay, the next one, it looked like a product rule, so keep the first one, take the derivative of the second one, plus put the second one, take the derivative of the first, right? So something like that. And at the end, you can see both of them have e to the x, both of them have x at least to the x power, so I can actually factor this. So again, I would suggest write down the question and don't look at my answer yet and practice it. So that's part of the quiz, and then that's the second part of the quiz that asks you to find. They give you a cost functions, and then they want to find the average cost. So average cost is just divided by x, right? So we can easily do that. And then they ask for the average cost for each of 800 units. So I just need to plug in 800 to the average cost functions. And the next one is the marginal cost. So we use the cost function. Anytime you need to do marginal, what do? You take the derivative of that. So you take the derivative of this, so easy enough. And then they ask the marginal cost of producing certain number of units, and you just plug in that number in there, right? So it's pretty straightforward. I can also ask question like this to find the marginal revenue or marginal profits. Just make sure you know how to find revenue function, right? Revenue function is what? Price times x units. If you need to find the marginal revenue, you just do the derivative, right? And then if I ask you for the profit function, remember profit function is what? Revenue subtracting the cost. Make sure you put a big parenthesis around the cost, right? If I ask you to find a marginal profit, you just like take the derivative of that, and they may ask you a certain number of units, and then you just plug it in. So you may have some questions like that. And I also have an uploaded quiz, so we want to go over the answer with you. So if you have the paper with you, you can double check to see you get the correct answer. So taking the derivative of e to the x is just e to the x. If you have a function in the exponents, then you write down that and then take the derivative of the exponents, right? So those are the basic rules. Make sure you know them. And the next one is ln of x is just 1 over x. But if it's ln of a function, then you need to take the derivative, put it on top, and then f of x at the bottom. So some of the book will say something like this, like 1 over f of x times f prime of x. That means the same thing. Alright, next one is the product rule. So u v prime plus v u prime. And then the quotient rule, so bottom is square. Start with the bottom, u prime, subtracting u v prime. Okay, and the next one is the chain rule. So chain rule, you pull down the exponents, write down the functions, the exponent is 1 less, and then take the derivative of the inside part. And the next one is the relative rate of change. So it looked like you basically put an ln in front of it, right? So it's the same as the ln with the chain. The percent rate of change is what you get from relative rate of change, but you need to multiply by 100, okay? The elasticity, inelastic is like when the number is less than 1. Elastic is greater than 1. If it equal to 1 is units. So inelastic means the demand is not sensitive to the price change. So it basically stay the same because of that, and the revenue will go up. If your price go up and people still ordering the same number of that, like toilet paper, then the toilet paper company is going to make a profit. Elastic mean if you raise the price, the demand is sensitive to the price change, and they will not buy anymore, and so the revenue will go down. So if something is not very important at this moment, like a new car, and they raise the price and we don't have extra money to buy a new car, so the demand is going down, then the car company revenue will go down. So alright, so we need to have some idea of that. And let's see here. On the next page, they say when you take the first derivative, you can see if the function is increasing, decreasing, or not constant, but like if the first derivative is positive, it means the function is increasing, going up. If the slope, the first derivative, is a negative number, that means the function is decreasing. If it's a 0, it's a horizontal line there, right? Which means that's likely it's going to be a critical values. All right. The next part is taking the second derivative. So second derivative, if it's positive, remember positive usually is happy, so you have a concave up graph like a cup, concave up like a cup, or smiley face. And then if it's that second derivative, you get a negative. Negative people is usually mad, right? So you have a set-based parabola, so it's concave down. If you have a 0 for the second derivative, it's inconclusive. So beside knowing the concavity with the second derivative, you could find the local extremer there too, because this would be probably have a minimum here, this would be a maximum here, and you also have the inflection points if they change concavity. So that's for second derivative. Let's see. So anytime if you want to know the marginal something, you're going to need to take the first derivative. If you want to know the average cost functions, you use your cost function divided by x, right? All right. On your quiz, you also have these two questions, right? And they're kind of lengthy. You will have something like this on the test, so make sure you practice that. And do I have the answer? So the first question looked like this is a third degree functions. We want to know increasing, decreasing, extremer, concavative, inflection points. So for sure, you're going to need to take the first and second derivative. You take the first derivative, set it equal to 0 to find the critical values, solve for x. I found 0 and 2. So using that, we are going to set the table, right? So you can use this to check your quiz answer, okay? If I plug in a number in those regions, if I get a positive, it means increasing. If I get a negative, it means decreasing. If I get a positive again, it means increasing. So you form like this shape of the graph. So you have a maximum here and a minimum here because of the increasing, decreasing part, okay? So we figure out this region and these regions are increasing, and the middle region is decreasing for the graph. And because we know a max and a means are here, to find those points, I need to use my x values and plug it back to the original function to find the y value. So 0, 0 is my maximum, 2, -4 is my minimum. All right. And so I take care of A and B parts. The C part asks for concavative, so I need to take the second derivative and set it equal to 0. I found out the point is x equal to 1. So I set the table again, set up the regions, plug in number in the region for the second derivative. One of them come with negative, it means concave down. One of them come with positive, it means concave up. So those are my concavitive interval notations. And because the concavitive change here, it means x equal to 1, that point is going to be my inflections point, right? So I plug it back to the original functions to find my inflections point. So that's number 14. It's a little bit cleaner than number 15, I think. So number 15 is a rational function, which is looking like a fractions, right? So again, they want to know increasing, decreasing, constants, and inflections points and concavitives. Okay, so taking the first derivative, you are going to need to use your quotient rule, finding that. So when you have a fraction, the difference is that you will set the top part and the bottom part equal to zeros, right? So you need to do that to find those critical numbers. So luckily, we only have one number, right? Yay! And then also, x cannot equal to 4, because if x equal to 4, the original function will have a 0 in the denominator, which is undefined, right? So I try to write myself a note, this is going to be undefined, so this is not really a critical number. It's not a max or mean. If later on, this is not going to be an inflections point, because x cannot equal to 4. Okay, so I plug in some number for the first derivative. When I get a negative, it means decreasing. When I get a negative again, it means decreasing. But be very careful. I see some of the students say decreasing is from negative infinitive to positive infinitive. That is not quite correct, because it got interrupted at x equal to 4. It's probably a vertical asymptote here, right? So the decreasing is actually negative infinitive to 4, and then it pick it up from 4 to infinitive. And I don't have any increasing parts. So that's the A and B parts, increasing, decreasing, and then extremer. No local extremer. This is A, this is B, right? Okay, and then I need the concavitive, so I'm going to take my second derivative, right? Second derivative, again, we use the quotient rule one more time, clean that up. I set the top equal to 0, bottom equal to 0 again. So luckily, again, the only number I got is x equal to 4. So I can use that to set the table, right? This time I need to plug in the second derivative. So let's see. One is negative, one is positive. So negative people is sad, so concave down. Positive people is happy, so concave up. So they change concavitive. Normally, this is your inflections point, right? But because x cannot equal to 4, so I don't have an inflections point, but I do have concavitive change, and I write down the region here. So this part is going to be the C and the D part, all right? Okay, so earlier we did this from one of the quiz questions. If we use all the information we get and we try to graph it, what would happen? So I'm going to pull out all the information we just did. We have the increasing, decreasing, maximum, minimum, concave up, concave down, and inflections point. So I'm going to write down on a piece of paper. This is what we get from one of the quiz questions, right? So if I have all this information, will I be able to graph it? So let's see. So this is a degree 3, A positive. So the end behavior should be something like that, right? The maximum term would be 1 less than the degree, so it's going to be 2. So your end result should be something like that. Following those information you have on there. So it looked like I have, let me see, relative maximum at 0, 0 is relative max, and then relative minimum is 2 and negative 4. Okay, and then we have concave down up to 1. and the inflection point is 1, -2. 1, -2 is here. So look like this is concave down like here, and concavity change, so and going to be like this. So some of the question may ask you to graph using the information you get, so you will have to figure that part out, okay? Alright, and if I want to, I can also find the intercept, so that may help me also. Alright, so intercept probably is like a 3 here. Alright, beside that, like there was a student asking me a question earlier. If you have a function that is a, I think it was on the quiz, and I forgot to do it. Okay, so if you have a chain rule like e raised to 6x minus 1, when you need to take the derivative, then you will do what? You write down what you have here, and then you take the derivative of the exponents, right? Like that. So this would be 6, this would be 0, so basically this is just 6 times e, 6x minus 1, right? So I hope that makes sense. I forgot to do that one. That was on your paper quiz. Let's see what else. You may have some question that I will give you a graph. Let's see. So if I give you a graph like that, you will have to figure out the increasing, decreasing, where is the relative maximum, where is the relative minimum point, and the critical points. So the increasing, you will look from left to right, right? So increasing is between x's -1 to 3. Increasing is -1 to 3. Decreasing would be this part and this part, right? So negative infinity to x equal to -1, and also starting from here, which is x equal to 3 to positive infinity, right? Do we have a relative maximum point? So the point, the maximum is here, which is x equal to 3, y equal to 3, right? And the relative minimum is over here, so it's -1 for x, -1 for y. So both of these 2 points would be considered as the critical point, so the maximum and the minimum. Okay, how about the second picture? So the second picture, I can ask you concave up, concave down, absolute max, and absolute minimum, and the inflection point. So concave up is like a cup here, so look like until here, right? So x is -3 to x equal to 2. Is that okay? -3 to 2. And then for the concave down, like a frowny face, it's going to start from x equal to 2 to x equal to 5. The absolute maximum is not the same as relative, right? Absolute means the highest point of the graph. The highest point of the graph for this one, because it stopped there, is going to be x equal to 5 and y equal to 4. And the absolute minimum means the lowest point of this graph is going to be here, right? So the lowest point is going to be x equal to 0, y equal to -3. Do we have an inflection point? What is inflection point? Inflection point is the part they change concavity, right? So concavity is going to be concave up, concave down, so this point, right? So this point look like x is 2 and y is 1. Alright, so you may have some picture given to you that you need to identify increasing, decreasing, critical points, and also concave up, concave down, and the inflection point, and absolute max, absolute minimum. So relative max and relative minimum just like up and down, down and up, but absolute max and absolute minimum is the highest point of the graph and the lowest point of the graph, okay? What else? So other things you need to know is how to find relative rate of change and percent rate of change. So we okay with finding relative rate of change and percent rate of change. So usually they will give you a function, say 30 plus 4x at x equal to 5, and then let's do the same one, f of x 30 plus 4x at x equal to 3. Okay, so the relative rate of change is going to be f prime of x equal to, imagine you put an ln in front of it, right? So it's going to be f prime of x over f of x. F prime of x on top, that would be just 4, right? And f of x is 30 plus 4x. And then we just plug in 5 to here. So we have 4, and then 30 plus 4 times 5. So 4, this is 30 plus 20 equal to 4 over 50 is 0.080. This one they call for 3 decimal places, so it's kind of look weird, right? Sorry. And then percent rate of change is almost the same thing, just need to multiply 100 in front of it, right? F prime of x, f of x. So I already got this here, so 100 times 4 over 30 plus 4x. That would be 400. 30 plus 4x, and then this time I want x equal to 3, right? So 430 plus 4 times 3, 30 plus 4 times 3. So we got 400 over 30 plus 12. 400 divided by 42 is going to be 9.5%. Okay. Alright, so you need to know how to find relative rate of change and percent rate of change. You may have questions that given you a profit function and ask you to find the maximum profits, how many units you need to sell, what is the maximum profits. So again, you're going to need to take the first derivative, which is negative 4x plus 280, right? And then we want to set that equal to 0. So negative 4x plus 280 equal to 0. 280 equal to 4x. So x equal to 70. So you're going to need to sell 70 units to make the maximum profit. So if I want to know the maximum profits, where do I plug that in? I should plug it to the original function. So let's see, negative 2 times 70 squared plus 280 times 70 minus 600. So hopefully you will get 9,200 for your maximum profit. So if it's a work problem, make sure you write an answer statement, okay? So there may be a question asked you to find the absolute extrema, so absolute maximum, absolute minimum. So remember, we need to find the critical value and then plug in the endpoint, critical values, and the endpoint to the original function to find it, right? So this particular one gives you a interval. So if it's not in the critical value, it would be those points, right? Either the end point, right? So I take the first derivative, is going to be 10t minus 30. That's it. Okay, and then set it equal to 0 to get the critical value. 10t minus 30 equal to 0, 10t equal to 30, t equal to 3. So 3 is one of the points along with -2 and 8, right? So I need to plug in h of -2, I have h of 3, and then h of 8. So on the test, show your step. After we plug it in, I got -2 is 84, 3 is -41, 8 is 84. So I have 2 points. They are absolute max, and then one is absolute mean. So absolute max value is 84 at the point at the point x equal to -2 and x equal to 8. So the absolute maximum point are -284 and 884, right? So I have 2 points for the maximum. The absolute minimum value is -41 at x equal to 3. The absolute minimum point is x equal to 3, y equal to -41. Alright? If you have questions, please let me know. Use your review along with this information to study for your exam. Thank you.